welcome to my video. My name is Mega Shafira and my ID number is 43014177089. In this learning chemistry video, we will learning to analyzing the factors that influence the shift in the direction of equilibrium and its application in industry. At the end of this lesson, we can describe Lee-Serrier's principle and use it to predict the direction that a reaction will shift in response to various changes. So far, you have learned about what chemical equilibrium means and how to calculate an equilibrium constant. Now, we'll be looking at a review of chemical equilibrium in industry, because many industrial processes are of course not complete or they don't go to completion. So we have to be able to manipulate chemical equilibrium so that we can get an advantage out of it. And to manipulate how we can get product effectively and efficiently, we have to look again at Lee-Serrier's principle, remembering that he was the guy that sort of developed our knowledge of equilibrium. So his principle is essentially a way to predict how an equilibrium system will adapt. If a stress is placed on a system at equilibrium, the system will proceed in a direction that minimizes the stress. So, if you impart a change on an equilibrium system, this equilibrium system will alter so that it will try to resist the change as much as possible. So, the factor that affect equilibrium is temperature, pressure or volume, concentration, and catalyst. Increasing or decreasing the temperature of a system at equilibrium is also a stress to the system. The equation for the Haber-Bosch process is written on next. The equation for the Haber-Bosch process is written like this. Ammonia as exothermic and nitrogen, hydrogen as endothermic. Repeat again. Ammonia is exothermic and nitrogen, hydrogen is endothermic. The forward reaction is the exothermic direction. The reverse reaction is the endothermic direction. If the temperature increases, the system will cease to absorb the energy in an endothermic reaction. For the Haber-Bosch process, concentration of ammonia in the system decreases, while the concentration of nitrogen and hydrogen increases. Conversely, for the Haber-Bosch process, a decrease in temperature favors the forward reaction. Therefore, the concentration of ammonia in the system increases, while the concentration of nitrogen and hydrogen decreases. Changing the pressure or volume of an equilibrium system in which gases are involved is also stress to the system. A change in the pressure or volume on a liquid or a solid has negligible effect. We will return again to the equilibrium for the Haber-Bosch process. Imagine the gases are contained in a closed system in which the volume of the system is controlled by adjustable piston as shown in figure. On the far left, the reaction system contains primarily nitrogen and hydrogen with only one molecule of ammonia present. As the piston is pushed inward, the pressure of the system increases according to Boyle's law. This is a stress to the equilibrium. In the middle image, the same number of molecules are now confined to a smaller space, so the pressure has increased. According to Lechetelier's principle, the system responds in order to relieve the stress. In the image on the right, the forward reaction has been favored, in which each one molecule of nitrogen combines with 3 molecules of hydrogen to form 2 molecules of ammonia. When the pressure is increased by decreasing the available volume, system responds by favoring the reaction direction that produces fewer gas molecules. A decrease in pressure on the above system could be achieved by pulling the piston outward, increasing the container volume. The equilibrium would respond by favoring the reverse reaction, in which ammonia decomposes to nitrogen and hydrogen. This is because the overall number of gas molecules would increase, and so would the pressure. When the pressure of a system at equilibrium is decreased by providing more total volume, the reaction that produces more total moles of gas become favored. This is summarized in the next table. A change in the concentration of one of the substance in an equilibrium system typically involves either the addition or the removal of one of the reactant or product. Consider the Haber-Bosch process for the industrial production of ammonia from nitrogen and hydrogen gas. This is an effect of concentration stress. If we are increased product, will be shift to increased reactant. And if we are increased reactant, it will be shift to increased product. Now, if we are decreased product, it will be shift to increased product. But when we are decreased reactant, it will be shift to increased reactant. Since a catalyst speeds up the rate of a reaction, you might think that it would have an effect on the equilibrium position. However, catalysts have equal effect on the forward and reverse rate. So for a system that is already at equilibrium, these two rates remain equal. A system will reach equilibrium more quickly in the presence of a catalyst, but the equilibrium position itself is unaffected. Thanks for watching and see you on the next video.